Now on to the matrices question 2. Here's our A, and we have to work out A squared, which we know is A times A. And using our matrices multiplication, we've got row times column, gives us this value, row times column, gives us this value, etc. until it is all complete. Equally A cubed, yeah, we could do A times A times A, but that's going to be much longer. Why not combine those two and just do A squared? We already know A squared, we worked it out over here, and we can work out A cubed. And we're trying to find a pattern. Well, it's looking like that the first column are both zeros, and that doesn't change. And it looks like the second column that the t is increasing, goes from really that 1 you could argue is t to the 0. So the first term is t to the 0, t to the 1, t squared or t to the 2, etc. Whereas this one is t to the 1, 1, 2, 3. So, my proposal for conjecture is that to any term, it's the term n on the bottom one, zeros here, notice. Let's go back and check. Yeah, 2 for squared, 1 for just power of 1. And over here, cubed for cubed. And this is 1 less than it. 1 less, 1 less. And that's why I've wrote up here 1 less. So now let's prove it. Well, we've got to do it as we do always. Start for the first term. The first term, alright, the left hand side, putting it into our formula would give us 0, t to the 1 minus 1, which gives t to the 0, and 1 on the bottom, and that is the value for A that we had over leaf. We assume that pk is true, and here's the same formula using this one here, and putting just k into it. We know we're going to have to use that at some point. That's why I've used the yellow here to highlight that. And we're going to prove pk plus 1 is true. So remember, for pk plus 1, we run the same formula, but instead of writing n in each of these places, we're going to write k plus 1. This top one, the plus 1 and the minus 1 cancel each other out. Whoops, I missed off a k there. And the bottom one, we get tk plus 1. Now don't forget, we're trying to prove this. So using the indices laws, we know that a k plus 1 is the same as a to the k times a. And we know a to the k already, we can use that. So this is what we're trying to prove here, remember. We've got a to the k, we can use it. So I'm going to replace a to the k with my a to the k and times it by a. And when I run through that multiplication, I get this. Let's break this one apart into tk. That's minus. Minus does not mean times t to the minus 1. So we could write that, rather than doing it divide, I could write that one as tk times t to the minus 1, and this t is still there as t to 1. And those two will cancel each other out to leave me with just t to the k. And the other one, don't forget there's a 1 there, so that will give me, okay, tk plus 1. And then when we check back, okay, we've got this is what we've just found, this is what we're trying to prove, and we can see that they're the same, and we include our induction blurb as normal. I hope that helps.